So we are going to start off by finding the measurements of all of the other angles in this picture except for the one angle that we were given. And we are going to use what we learned about special angle pairs last week in order to do that. So I'm looking here at angle 1, this 120-degree angle. I see another angle up here that is the exact same size, that is also 120 degrees. What would be another angle that's exactly 120 degrees? Angle 4. What's the relationship between this angle and this angle? They're vertical angles. And vertical angles are always congruent. So angle 4 is 120 degrees. I can always pick out vertical angles as being congruent. I see on this picture that we have an extra arrowhead on each one of these lines. Does anybody remember what that means? That they are parallel, yes. And when we know we have parallel lines, we can make relationships between two intersections. So I'm going to be looking over here and comparing it to angles over here. And I should be able to find two angles over here that are also 120 degrees. Which other angles are also 120 degrees? 5 and 8. Absolutely correct. Angle 5 and angle 8, in addition to angle 4, is congruent. We're going to write that down over here, and then we're going to talk about why. This 120-degree angle and angle 5, does anybody remember what we call that special angle pair? When I look over here, the 120 degrees I notice is in the upper left corner. And when I look at this intersection, angle 5 is also in the upper left corner. What do we call the matching corner angles? Close. That means same side. Consecutive always has to have an interior or an exterior with it. Are both of these angles interior?
Yes.
No, they are not. They are not both in between these parallel lines. In order to be interior, they are corresponding, yes. My interior angles would be all the angles in between those two lines. So those angles right there. 120 degrees and angle 5, these are corresponding angles. Yes. Corresponding angles. And when the lines are parallel, they are congruent. All right. And then let's look at the 120-degree angle and angle 8. What are those two angles called? Are they interior or exterior angles, or do we have one of each? They're both exterior. They're not in between these two parallel lines. Again, my interior angles would have to be the ones in this space. So they're both exterior. Same side or opposite sides of the transversal? Opposite. And so we call these, yep, alternate interior angles. And when the lines are parallel, those alternate interior angles are congruent.
I have a couple of questions because I'm still kind of confused about these lines. So, first of all, so how do you know if the angles are interior or exterior?
Is it in between the two parallel lines? So here's one parallel line, here's the other parallel line. Interior are the ones that are in between those. So 2, 4, 5, and 7 are my interior angles because they are in between the two lines.
Oh, okay.
Yep, if it's not in between, it cannot be interior.
Okay. So, looks like that angle for angle 8 are on the same side, so how they're not?
Which angles?
3 and 8.
3 and 8 are on the same side of the transversal, but they're not interior angles.
Okay.
Yes, 3 and 8 are on the same side of the transversal, though.
Looks like you wrote alternate interior angles under 3 and 8.
Oh, you're right, I did. I should have written exterior. Thank you for catching my mistake.
Yeah.
Alternate exterior angles. My bad. Because they are not in between. I'm sorry that I caused confusion.
Yeah.
All right, so let's look at these other 4 angles up here. We have angle 2 and angle 3, angle 6 and angle 7. The only angle that we were originally given was this 120-degree angle. What's the relationship between the 120-degree angle and angle 2? What do we call that special angle pair? They make a line, so they make 180 degrees. What do we call that pair? They're a linear pair. And linear pair angles add up to how much? 180. So I know that 120 degrees plus the measure of angle 2 equals 180 degrees because they are a linear pair. So how big would angle 2 have to be then? 60 degrees. Angle 2 is 60 degrees. All right, so if angle 2 is 60 degrees, how big is angle 3? Also 60 degrees. We could either say because it's a vertical angle with angle 2, or we could say because it's a linear pair with that 120-degree angle. All right, so if angles 2 and 3 are both 60, how big is angle 6? Also 60. Remember, angle 5 is 120 degrees, and 5 and 6 are a linear pair. Or you could look at it and you could say that angles 2 and 6 are corresponding, so they have to be congruent. Or we could say that the 120 degrees and angle 6 are consecutive exterior angles. They have to add to 180. They're supplementary. How big is angle 7? 60 degrees. Nice work.
So what do you say about the consecutive exterior angle?
Consecutive exterior, the 120-degree angle and angle 6. Do you see how they're both exterior angles?
Oh, yes.
But they're on the same side of the transversal. They're both on the top of the transversal. Consecutive exterior angles are supplementary. They add to 180. Same thing for my consecutive interior angles. They're also supplementary. They add to 180.
5 and 6 are?
5 and 6 are a linear pair.
Oh.
The 120-degree angle over here that doesn't have a name with it, we could call it angle 1. This angle right here and angle 6 are consecutive exterior angles.
Okay, because they add to 180.
They add to 180, yes.
Which makes them consecutive?
No, what makes them consecutive is that they're on the same side of the transversal.
Okay.
And then they're exterior, and because they're consecutive and exterior and the lines are parallel, that's what makes them supplementary. All right, let's see if we can use some of these angle relationships to solve some problems. We're going to look down at number 7, problems A and B. Let's look at A first. So I'm going to redraw the picture that we're given here so that I can mark it all up. All right, so something like this. We have lines J, K, and L. Then we have angles 1, 2, 3, 4, 5, 6, 7, and 8. Something like that. Angle 3, which is this angle right here, is 4x plus 7 degrees. And angle 6, this angle right here, is 5x minus 13 degrees. What's the relationship between angles 3 and 6? What do we call that angle pair right there?
Angle 3, angle 6.
Angle 3 and angle 6. We would describe them as what? Are they alternate? Are they consecutive? Are they interior? Are they exterior? Alternate interior angles, yes. Angle 3 and angle 6 are alternate interior angles. And so they are congruent or supplementary because they're alternate interior. They are congruent. Alternate interior angles, which are congruent. So angle 3 is congruent to angle 6, which means what about their measurements? They're the same. So the measurement of angle 3 is equal to the measurement of angle 6. So in the place of angle 3, we're going to put 4x plus 7. In the place of angle 6, we're going to put 5x minus 13. And now we're going to solve this for x. So the first thing I want to do is get my x's to the same side. So I'm going to minus 4x from both sides. So I get 7 equals what? One x minus 13. So 7 equals x minus 13. Then we're going to add 13 to both sides to make that minus 13 cancel out. And so x is how big? 20. 20 equals x. All right, let's do part B then. Part B, we want to find y. And they tell me that the measurement of angle 8 is 68 degrees. So this angle right here is 68 degrees. And then it tells me that the measurement for angle 3 is 3y minus 2 degrees. So I need to find a relationship so I know whether to set them equal or I know whether to add them and then equal them to 180. So I'm looking at angles 3 and 8. Are those both interior angles? Are they both exterior angles? So now I have to check to see if they're corresponding. Corresponding is my matching corners. So here, when I look at angle 3, that's on the top, right? Where those two lines are crossing. Over here is angle 8 also on the top. No. Are they matching corners then? They're not corresponding. So I just ran through all of them that I know. They're not vertical angles. They're not a linear pair. They're not both interior, so they can't be consecutive interior or alternate interior. They're not both exterior, so they can't be consecutive exterior or alternate exterior. And they're not corresponding. So I'm going to have to find a different relationship here. I'm going to look over here at angle 8. If I'm looking just at this intersection where angle 8 is, I know there's another angle over there that's the same size as 8. 5, because they are vertical angles, yes. So this one is 68 degrees because these two are vertical angles. And vertical angles are congruent. All right, so now let me look at these. Are these two angles both interior?
Yes.
Yes, so now I'm going to be able to find a relationship. Are they alternate interior, where they're on opposite sides of the transversal, or are they consecutive interior? consecutive interior angles. So angle 3 and angle 5 are consecutive interior angles. Are consecutive interior angles congruent or supplementary? Are consecutive interior angles congruent or supplementary? They are supplementary. So that means they're going to add to 180 the measurement of angle 3 plus the measurement of angle 5 equals 180 degrees. We know that angle 3 is 3y minus 2. And we know angle 5 is how big? 68 degrees. So I have 3y minus 2 plus 68 equals 180. Let's combine our like terms, our constants together. What is negative 2 plus 68? So 3y plus 66 equals 180. And then I'm going to subtract 66 from both sides. So 3y equals what? 180 minus 66. 114. So 3y equals 114. And then I'm going to divide both sides by 3. And I get that y is how big? 38. Not degrees on this one because it's not an angle. We only put degrees on it when we're finding an angle. I'm glad you're looking for it though.
Okay. So, do all corresponding angles equal to 180 degrees?
Only if the lines are parallel. Okay. And it's consecutive interior. Are consecutive angles. If they're corresponding, they're the same size.
Oh,
yep.
So they're consecutive interior, they're equal to 180?
If they're consecutive interior, they add to 180. They're supplementary, yes. How did I know from the picture that these were parallel lines? The arrows, they have these extra arrowheads on them. If I didn't see those pieces, I couldn't have done either part of this problem. I have to know the lines are parallel, or else we don't have these relationships that hold up about congruent and supplementary between the two intersections. All right, let's flip the page. Let's review all the different special angle relationships that we talked about on Friday. All right, so first we're going to redefine interior angles. Interior angles are angles that are between two lines cut by a transversal. Angles between two lines cut by a transversal.
I think just for me personally, maybe for some other students, I think it would probably help if you kind of drew a little example for each.
We're going to do an example as soon as we write this all down. That's what the very next problem is.
Okay.
Yep. Good question, though. Exterior angles are angles that are not between two lines cut by a transversal. So interior angles, angles that are between two lines cut by a transversal. Exterior angles, angles that are not between two lines cut by a transversal. My vertical angles Vertical angles are opposite angles formed by intersecting lines. So when I see my intersecting lines like this, the angles that are on opposite sides are my vertical angles. Vertical angles always have what relationship to each other? Congruent. These are always congruent. Linear pair angles are not opposite, they are adjacent angles that together make a straight line. So if I'm looking at a picture, linear pair angles would be something like this. I have one angle here and a differently sized angle over here. And together they make a straight line. Linear pair angles always have what relationship? Always supplementary, yes. I'm going to abbreviate supplementary so that I have room to actually fit it in. These are always supplementary angles. Vertical angles and linear pair angles can be found with a single intersection, just an X. Corresponding angles, and then my alternate interior and exterior, my consecutive interior and exterior, these have to have two intersections. So I have to have two lines that are being cut by a transversal. Corresponding angles are angles in matching corners. Angles in matching corners. So if I have two lines cut by a transversal, matching corners like these two. When the two lines are parallel, then my corresponding angles are congruent. Alternate interior, alternate exterior angles. These are opposite sides of the transversal. Opposite sides of the transversal, and each touching a different line intersected by the transversal. When the two lines are parallel, these will be congruent. That means parallel.
Oh.
That means parallel. That was one of the things that we wrote down last week when we saw that symbol for the first time.
Oh, okay.
Yep, that's okay. I know it's still a new symbol.
Okay.
Consecutive interior or exterior angles. These are on the same side of the transversal. And each touching a different line intersected by the transversal. And for my consecutive angles, whether it's interior or exterior, when the two lines are parallel, then these angles are supplementary. When the two lines are parallel, then the consecutive interior, consecutive exterior angles are supplementary. All right. Let's do an example where we have to look at some of these. So I'm down here at number 9. We're going to list all of the interior angles. Which angles here would be my interior angles? Yep, 3, 4, 5, and 6. Those are in between the two lines. So angle 3, angle 4, angle 5, angle 6. What would my exterior angles be? 1, 2, 7, and 8. Yes. Angle 1, angle 2, angle 7, and angle 8. Alternate exterior angles. If we're doing alternate exterior angles, we don't care about any of the stuff that's in between the two lines. Which angles would be alternate and exterior?
2 and 8 and 1 and 7.
2 and 8, 1 and 7, yes. Angle 2 and angle 8. Angle 1 and angle 7. How about my alternate interiors? Now I don't care about the exterior angles at all. I'm just looking at my interiors. would be the alternate interior angles? Yep, 3 and 5, and then 4 and 6. Angle 3, and angle 5, angle 4, and angle 6. They're alternate because they're on opposite sides of the transversal. Angle 3 is above the transversal, angle 5 is below it, and they're both interior angles. Similarly with 4, 4 is below the transversal and 6 is above the transversal. All right, part E, we're going to list our corresponding angles. Corresponding angles are my matching corners. Matching corners. So I'm going to look at one intersection here. How many corners are there? 4 corners when I look at just one intersection. So as I'm matching up my corresponding angles, I'm going to have 4 different pairs. Angle 1, I'm going to look at this angle here. That is in the lower left corner where these 2 lines cross. What's in the matching corner over here? 5. So angles 1 and 5 are corresponding angles. What would be corresponding for angle 2? What would have the matching corner on the other intersection from angle 2? 2 and 6, yes. Angle 2 and angle 6. They're both in the upper left. What about corresponding angle for angle 3? Angle 7, they're both upper right. Angle 3 and angle 7. And so then what would be corresponding for angle 4? Angle 8, lower right, lower right. Angle 4 and angle 8. All right. We've got 2 more to go. We have consecutive interior and consecutive exterior. Consecutive means same side of the transversal. And for part F, we're going to do just the interior angles. So I don't care about any of these outside angles here. So we're only looking at 3, 4, 5, and 6. And I want ones that are on the same side of the transversal. So give me a pair of consecutive interior angles. We are on page 5. Yep, I want a pair of consecutive interior angles. Angle 3 and angle 4 both touch line M. I need them to touch the 2 parallel lines. Those are a linear pair, so they do have a special relationship, but they're not consecutive interior. I need one to touch one of my parallel lines and the other one to touch the other parallel line. They'll both touch the transversal, but that should be the only thing that they have in common. 3 and 6, yes. Angle 3 and angle 6. What would be another pair of consecutive interior angles? 4 and 5. All right. So now that we got our consecutive interiors, let's look at our consecutive exteriors. Since I'm switching my attention to consecutive exterior, I don't care about any of these interior angles in here. I need angles that do not touch each other, but are on the same side of the transversal. What would be a pair of consecutive exterior angles? 2 and 7. What else? 1 and 8. Fantastic. All right. So down at the bottom here, we're going to talk about our special relationships when the lines are parallel. We have some angle pairs that are congruent. My congruent angle pairs when the lines are parallel are my corresponding angles. My alternate interiors and my alternate exteriors. And there's one other that I can think of that we learned about before we learned about corresponding and alternate interior and alternate exterior. What's the other special angle pair that we learned about long before these that are congruent? Looking for a word that starts with a V. Vertical angles. So we have 4 special angle pairs that are congruent to each other. My supplementary angles would be which ones? What would my supplementary angle pairs be?
2 and 7.
Not looking for numbers, I'm looking for types of angle pairs, like we wrote on the line above, corresponding, alternate interior, alternate exterior. You're right, 2 and 7 are supplementary. What kind of angle pair did we call 2 and 7? Yep, what did we name that angle pair in the problem right above it? We said they were what type?
Exterior.
Consecutive exterior angles. Consecutive exterior angles. What's another special angle pair that is also supplementary? Angle 1 and angle 8. Again, I'm looking for the names of the special angle pairs that are supplementary when the lines are parallel. Angles 1 and 8 would also be consecutive exterior angles. I want another type of angle pair that would be supplementary. Consecutive interior angles. So we have consecutive interior, consecutive exterior, and there's one other that I can think of that we learned about before all of this. We learned about it at the same time as vertical angles. Linear pair. And for these last 2 that we just wrote down on the ends of each list, vertical angles and linear pair angles, this is always true whether the lines are parallel or not. Even if the lines aren't parallel, my vertical angles will still be congruent. My linear pair angles will still be supplementary. All right. Let's turn this over to page 6. I think we have enough time for the problem up at the top of the page, number 10, and then we'll have to hold off on the rest of these until tomorrow. So on number 10, we want to know the relationship of all of the listed ones to angle X right here. What would be the vertical angle to angle X? Angle Z. There's two angles up there that make a linear pair with angle x. What are the two angles that make a linear pair with x? Yep. Give me one linear pair. X and y are a linear pair. And angle W, yes. Angle Y and angle W. What would be the corresponding angle to angle X? Now I'm looking for the matching corner. Which one? Angle A, yes. Angle A. Angle X is upper right. Angle A is also upper right. What would be the alternate exterior angle to angle X? Angle which one? Not B. They are on alternate sides, but angle B is not an exterior angle. He's on the inside. He's in between these two lines. C. Angle C would be the alternate exterior angle here. What would be the consecutive exterior angle? If C is the alternate exterior, what would be the consecutive exterior? D. Angle D. All right, last part of this question. Which angle did we not talk about? Which angle did we not match up? Angle B. The relationship with angle X is that those would be supplementary. These we only did exteriors because X was an exterior angle. Okay. All right. Ladies and gentlemen, on Friday I told you your homework was due on Tuesday. We did not get through everything we needed to, so your homework is not due until Wednesday. I'm bumping the due date out one day. Homework is due on Wednesday this week. Have a great rest of your day, guys. I'll see you tomorrow. Thank you.